بسم الله الرحمن الرحيم.
Hi, and welcome. My name is Deb Burke, and I'm in charge of the Battery Systems Group here at Canoo. I've spent the last 20 years working in the battery industry. Fortunate to start my career in Detroit at a Tier 1 battery system supplier, delivering battery packs to General Motors and the likes. Starting off my career in Detroit served as a good foundation for the electric vehicle startup environment that I'm in today, where we have the opportunity to design a battery pack from the ground up. And I'm really excited to share with you today what we've been working on over the past few years. But before we get started, I'd like to provide a brief overview of the typical approach for battery packs, and that is packaging the modules inside big, bulky enclosures. As you can see here, with the Canoo pack, we don't have that enclosure. That saves us roughly 40 kilograms, enabling us to get upwards of 200 watt-hours per kilogram in specific energy. This design is functionally and structurally integrated, helping with the vehicle overall performance. Now, how did we do that? With this battery module right here. This is in-house designed by the talented battery team at Canoo. It is compact and modular, which means it's scalable across multiple battery pack configurations. This is important for leveraging economies of scale and streamlining high volume production. The battery module is comprised of three major subsystems: the cell, the cold plate, and the interconnect board, or ICB. The cell we source from one of the largest reputable battery companies on the globe. And here's the cold plate. Also happens to be Canoo's first patent issued. It is novel for its structural and mechanical integrity. The cells are glued inside the cold plate, and the design is agnostic to the vendor, meaning we can buy this battery cell as long as it's in the 2170 format. We can buy this battery from any supplier on the globe. This is also important for being able to grow with battery technology as it evolves. The design is very flexible. The interconnect board is the power distribution array responsible for putting the cells in their parallel and series configuration. The ICB is laser welded to the cell can. You might have seen it in the video clip behind me. In Torrance, on our pilot production battery line, we developed this technology. And all of this technology is carried over to our mass production battery line equipment. On the table in front of me, we have two pedigrees of parts, and you can see the improvements and the advancements we've made in just a short few years. This is the beta cold plate compared to the gamma cold plate. We went from a 4-part assembly down to a single part with a proprietary insulative coating. This is the ICB improvement. We have a larger assembly, so our BOM cost went down and the BOM number of components went down. We went from a dual layer design to a single layer design. There are 16 of these battery modules in the battery pack, along with other critical sub-functions, which include the coolant system, the high voltage bus bars, and the battery management system, and the brackets. The brackets are what are attached to the battery modules. So the brackets plus the cold plate provide that structure and stiffness required to meet the rigor of the vehicle crash requirements. The bolted connection is important as that enables our serviceability. You can appreciate the size of this battery module compared to our competitor's battery module. To service this, we simply lower the battery pack out of the vehicle and unbolt the battery. This level of serviceability is roughly 1/3 the replacement cost compared to our competitors. You can see the difference in size. This is important because it gives back to the consumer in the form of reduced replacement and repair cost. Thank you very much. My team and I have been very excited to work on this for the past few years, and more excited to see it integrated into the multi-purpose platform for our high volume production vehicles.
Welcome everybody, my name is Charlie Garmel. I'm in charge of the powertrain engineering team here at Canoo. My background is in transmission design and development for helicopters, and I had the opportunity to work on some clean sheet designs in which I was able to break down some barriers in that aerospace industry and work on some new products. With that, I had the opportunity to join Canoo and break down some of those legacy barriers in the automotive industry. What I have in front of me is one of those barriers. What you have here is a 350 horsepower motor. That's literally millions of these have been sold, and they're in very many cars throughout the US auto fleet. In front of us is our Canoo drive unit, and you can see the sheer size difference between these two parts. The internal combustion motor weighs approximately 650 pounds, where ours weighs 200. One of the opportunities that we have here at Canoo is that we're able to take that weight savings and give it right back to the user in terms of mass, efficiency, and packaging space. Some of the other things I'd like to point out are the complexity of this system against ours. We've dropped the part counts significantly, and we think that with a lower part count becomes a higher durable and more reliable system. I'd also like to point your attention here to these 10 liters of oil in front of this system. It takes 10 liters of oil to fill and run this system. You also have to change that oil every service interval for that internal combustion system. But here at Canoo, we've designed our drive unit to set it and forget it. So we fill our oil at the factory, and you never have to change that throughout the life cycle of the vehicle. Here at Canoo, we have intellectual property throughout the drive unit. So we have a 3-in-1 system. What that means is that we've packaged the power electronics, the electric motor, and the gearbox all in one confined system. And we've done that for a couple different reasons. The first is packaging space, and we'd like to give as much of that space that's normally take internal combustion engine back to the user. And this engine here weighs approximately 650 pounds, where ours weighs 200. So in terms of volume and mass, we're able to give that back to the user and give it back to the occupant in terms of range and packaging space and just that overall flat skateboard architecture and open feeling in the vehicle. So I talked a little bit about the power electronics, and I'd like to just discuss one of the early on packaging decisions that we made with this drive unit. we decided to package our power electronics directly mounted to the drive unit here. It allows us to get rid of some costly components throughout the system and really provides that small, dense, power dense system in the vehicle for us. Let's talk about some of the components here. So what I have in front of me is the bar wound stator. It's a oil-cooled system and the permanent magnet rotor assembly. So when these two are combined together, they make up the Canoo electric motor. This motor was designed in-house. We do have intellectual property and patents on this particular system, as well as others around the system. It's something the team has worked very hard on, and we're very proud of the internal design capabilities here at Canoo. As we kind of progress through the line here, I'd like to show you some of the other components in the system. So here at Canoo, we design all of our castings and gear system in-house. The sum of these components make up a 9-to-1 reduction ratio for the transmission that we run here in our rear drive unit. This system is a modular design, so we're able to package and protect for some of the different vehicles and top hats that will be on top of that multi-purpose platform. We think that having a modular and scalable transmission system, motor, and 3-in-1 drive unit affords us some opportunities in the marketplace in the future. So I'd just like to point out some of the kind of intricate details around this particular system, where we have our differential assembly, our intermediate assembly, and the rotor shaft that you see there, which makes up our rotor assembly. One of the technologies we're most proud of here at Canoo is our internal oil cooling for the hairpin wound stator. As we direct cold jet lubricant over the hairpins in the stator, we're able to package industry-leading power dense design that's 13% more power dense than our leading competitors. Thanks for spending the time with us today. Here at Canoo, we're really excited to show you what's next and package this drive unit into our multi-purpose platform.
Hello everybody, my name is Minu Shah. My responsibility at Canoo is in charge of crash safety and occupant protection. I have been in this field for over the last 45 years. I have worked at Ford Motor Company, that's where I started my safety career. Then I worked about 13 years at General Motors, 12 years at Delphi, then about 4 years in India for one of the Indian manufacturer. When I came back, I joined Tesla, and I was responsible there for the Model 3 crash safety. And in 2018, this exciting opportunity came up, and I was so excited to do something totally ground up with the new technology. So I joined Canoo in 2018. Now, let me explain what we did and what is our philosophy. Our philosophy here is to protect, number one, to protect the occupant of the vehicle. Number two, to maintain the integrity of the occupant compartment. And number three is to maintain the safety of the electrical battery, because these are high voltage battery. In order to do all these things, we conducted over 12,000 virtual simulations in various configurations, including some real world scenarios. And then we built the beta vehicles. We crashed over a dozen crashes using the beta vehicle. Beta properties are very expensive. So each vehicle we used twice, which I'm going to show you here. Before we get into the beta, we went and used the subsystem level testing. And that's what I'm showing you here. So these are like crush cans, we call it. These are mounted to the platform and bolted on. So in an unfortunate event, if there is an accident, a fender bender kind of thing, it can crush, you can unbolt it and remove it and throw it out and replace with the new one. So this is the frontal crush can. In front, they absorb about 80% of the crash energy. This is the side crush can. And interesting thing here is, we developed this is our invented, patented technology. We developed this thing in-house, and we tested a lot of subsystem component level, straight crush. This represents like car is skidding and impacting into a pole or tree, and whether it absorbs the enough energy or not. These crush cans are packaged into the side rocker area. This is unique to the auto industry, and I'll explain it to you in a little more detail. So this particular vehicle you are seeing here is a 35 mile per hour frontal crash vehicle, which is used for the calculating the US NCAP star rating. And same vehicle was turned around on the right hand side and impacted with 38.5 mile per hour side moving barrier, which represents our car is trying to make a turn and other car is coming and hitting into us. This is about 5 mile per hour greater test speed than actual regulation test. Both of these test condition goes into the US NCAP star rating calculation. Based upon all the testing we have done and all the crash testing we have done and virtual crashes, we are anticipating to get 5-star overall US NCAP rating. So as you can see, the structural compartment integrity was very well maintained in this crash. And even the vehicle is still rolling after the crash, 2 crash tests. Now, let me show you dynamically what happened here. In this particular scenario, the frontal crash 35 mile per hour, and in this particular is the side crash. In the overview, you can see occupant hardly moves. See, occupant went into the airbag and just rebounded. And in the next shot, you will be able to see another philosophy which we have is to maintain the integrity of the battery. The yellow part is the battery compartment was intact. So now let me show you what I meant by structural integrity of the occupant compartment. In this particular vehicle, look at the floor pan. On the impact side, side impact side, there was hardly any wrinkle into the floor pan. The entire seat integrity was maintained. Typically in this kind of a crash, the deformation gets up to the seat and seat gets deformed. In our case, there was no deformation of the seat or seating area. Thank you very much for your attention, and I hope you learn a little more about our vehicle and our philosophy, what I explained in the video here.